basic differentiation rules. We're continuing on. I'm going to forego the derivations with the limit process, but always we can do those separately and show them to you. I may make a separate video of just those derivations. So there is a way to derive what the derivative of sine of x, what the derivative of cosine x is, and e to x. So here they are. So these are just as important as the power rule that they need to be memorized. So the derivative of sine of x is cosine of x. Okay. The derivative of cosine of x is negative sine of x. And the derivative of e to the x, this will be the hardest one you do, is e to the x. That's an easy one. Okay? And then I went ahead and put power rule back up there, just as a reminder. All right. Exponent moves down in front, subtract 1 from the exponent. And then the other couple rules that we'll use a lot of, remember, if you have a constant multiplied by your function, and you want to take the derivative, remember this is the operator for taking derivative, d over dx. This means find the derivative. It's k times f prime of x. So you just multiply by that constant. Now, everyone remember if we have multiple functions added or subtracted, right? You just take the derivative of each one and add and subtract those answers, okay? So using everything that we have here and what we have on the board, we should be able to find each derivative, okay? So I've got 4 examples, and each part, so the last 2, you may need some hints on how to attack it. In this second equation, you probably need to change square root of x to what?
X to the 1/2.
X to the 1/2. You don't have a rule. You need to write it as a power. Okay? So that would be the only thing. Now everything else should match up. Every one of these 4 up here have a rule. Okay? So go ahead. We'll do this. We'll time it for a minute. We'll give you a minute, and then we'll do part A. A minute, then we'll do part B. So I'll time it for a minute. See if you can get part A done. Finish part A, of course, move on.
They get your temperature when you came. What about you guys that were here? They get your temperature?
Yeah.
Cool as ice.
Okay, so that's been about a minute. Been a little bit more than a minute. So let's look at part A and see what we got. So really, all I need to worry about is the derivative of e and the derivative of cosine x. And the 7 multiplies and the negative multiplies. So when I go to take derivative, it's going to be 7 times. Well, what's the derivative of e to the x? It's just a memorization at this point. It is e to the x. Minus, what's the derivative of cosine x? Yeah, so that minus is here, and then you look at cosine, well, we know the derivative is negative sine, and now to get our final answer, we'll make those minus and negative into a plus. So 7e to the x plus sine of x, and that is our y prime, and that gives us our formula for our tangent lines, okay, for our slope of our tangent lines. Seems weird, but it does, okay? So just to get step one out of the way on this one, I would rewrite f of x. And this is something you'll see in the homework that they may have you do algebra before you do any calculus. They say rewrite it. So it needs to be a literal matchup. Is this x to the n? Yes. Something times sine x, that's fine. So I can do that, okay? I have the sine x there. So go ahead with that and then we'll talk about some that we can't do. Yeah, we're not ready yet, we don't have rules. And another rule is don't write your answer with a negative exponent. Try to make it positive. Okay, so we're ready to look at this one here? All right, so let's see. So when I take the derivative of this is a power rule, so the 1/2 goes where? In front, x, then I'm gonna go ahead and write, I take 1/2 and I do what to it? Subtract 1. Plus 2 times the derivative of sine is cosine. All right. So technically, this is the derivative, but algebraically, it's not very presentable there. So let's see. So 1/2 minus 1, you can't do that in our head. That's what? Minus 1/2, right? So we have 1/2 x to the negative 1/2 plus 2 cosine x. So it is, we say it's taboo to, in our answers, to leave a negative exponent. And it comes to when we're looking for values that are where we're not differentiable, it's easier to see it in a denominator. I'll explain that here in just a second. So if I ever have a negative exponent, if I move the location of this expression in the fraction, it changes it to a positive. So what I'm going to do is I'm going to write this 1/2 x to the positive 1/2. So that x goes down here with the 2, and that makes it a positive. And the last thing, since we started with a square root, I'll end it with a square root. And so I'll make this 1/2 square root of x plus 2 cosine x. It's not necessary to rationalize. You can just leave your answer like that. Now we can see it's more, when we write it back with the square root and we write it back we eliminate the negative, we can see we're not differentiable where? Where can I not take the derivative? 0, what else? Because of domain. 0 is exactly right. That's why you see it here, because you can't divide by 0. But there's another type of numbers. Yeah, anything negative. That's not even in the original domain. But 0 was in the original domain, but now you can't take the derivative there. Okay. All right, board's becoming a little jumbled. So I'm going to erase this work here. And then we'll look at C and D. Now, I'll give you a hint on C before you get started. The issue is, now in terms of how our equations are written, if I have a multiplication by a number, I can differentiate. If I have addition and subtraction, I can differentiate. I have subtraction, but I don't have a rule for dividing by x. So right now, this x down here is what's throwing everything off. You don't have a rule for division, okay? Let me erase this stuff here so we can create more of a focus. So now when I go to work this, I'm gonna do some algebra before it's ready to go. What I'm looking for is I can see, well, the only rule I'm gonna be able to use is power rule because I don't have a sine, I don't have a cosine, and I don't have an e. But in order to use power rule, I have to have x to a power plus or minus x to a power, etc. No fractions. Well, very simple. I can just divide each of these by x. I can make it x squared over x reduce minus 4x over x reduced. So split it into two fractions, reduce your fractions, and then differentiate. You see it's a 1 second problem. Okay? And then while we're down here, same idea. We don't want to leave this here. You're going to have to make some kind of adjustment in order to differentiate with that square root of x. Okay, let's look at this answer. Now I went ahead and grabbed the function above it, so we can cancel an x, and we're rewriting g of x as x minus 4. This is something that we would have done when we were simplifying limits, if you remember. And now if I take the derivative, well, it's just a linear function, and so what's the derivative of x? So don't overthink this one. So if it's just x, what is the slope of, what's the 1? Just always 1. Right? Derivative of 4 is 0. Remember, the derivative of mx is m. Right? You get 1. Now, here's the only thing. Technically, on this problem, there's one spot you can't take the derivative because of the original problem. I went ahead and showed that there's a hole at 0, right? Because if I try to plug in a 0, I get 0 over 0. It has a hole. So technically, even though this is your equation here, g prime of 0 does not exist because at 0, it's a discontinuity. Remember, if it's discontinuous, you can't take the derivative, okay? So it's important to kind of refer back to the original function, seeing that I can't plug in a 0, there's no point. Okay, and then the last problem, if you just rationalize, multiply top and bottom by square root of x, that will then move this up. We get 6x square root of x over x. These x's cancel, and I'm almost ready for power rule. I have 6 square root of x, which I'll make back to 6x to the 1/2. And then I go and do my power rule there, and let's see what you should have got. 6 times 1/2 x, and by now you know on a square root, when you change it to a 1/2 and you do derivative, what's the exponent going to be? Every time. Because if you move a half in front and you subtract 1 from a half, your exponent's always going to be what? Yeah, negative 1/2. And then, so that 2 into 6 gives me 3x to the negative 1/2. Do we want negative exponents in our answers? We know the answer to that is no. So we put the x in the bottom. And the very last step, and instead of even get x to the 1/2, we're going to make it square root of x. If I have room to squeeze it in my video, I don't, so I'm just going to change it there. There's your answer. Okay. Now, these are just some basics. Get into that 2.2 homework. All right, go in there and work through it. then when we come in on Monday, we can take some questions and look at some of those problems, because this is just the tip of the iceberg on some of these. It can get a lot more difficult, okay? All right, does that help a little bit on these two where I did some algebra? Okay, so everybody see what I did here? I rationalized so that this square root goes up and I get rid of because I don't want a denominator. Okay, all right. That's part two. There'll probably be a part three. This stuff is